Welcome everyone. Welcome to another episode of Coding Talks. Myself Vishnaviji. This episode focuses on AWS networking foundations. So this will help you to build scalable network architectures. Even though you are a developer or an architect, still you benefit a lot from this episode to get you a good understanding about the AWS network concepts, especially the fundamentals, which can help in your application development journey, especially if you are using AWS services. So those of you who are working in other cloud vendor can also listen the episode and can understand. We will get some benefits, learnings from this podcast. Usually, even though the cloud providers are very different, that you still the underlying concepts of these different services will remain the same. There will be some service specific, provider specific changes, which of course will be there, but still the basic underlying concepts remains the same. So you can still get some learning out of this. And the reason for this podcast is that myself, I am a .NET developer and I work with the different cloud vendors, including AWS. So some of the time, especially during the modernization journey, we have to migrate our existing applications, legacy applications to AWS infrastructure or Azure or GCP. So that time, most of the time, the network architecture fundamentally differs in cloud. And I have noticed that most of the time, there will be a specific team dedicated to set up this network infrastructure in the cloud, especially during the modernization journey, or even if it's a new, you're getting started with a new first workload in AWS, still there will be a separate team for that in most of the cases. In some organization, there won't be, and the developer itself manage that, but otherwise there will be a separate network or infrastructure team which can help you in this modernization journey. Still, if you understand this concept from a developer or architect perspective, it will help anyway. And security is one of the critical requirements for AWS, and AWS considers this security very seriously. So they develop services with security in mind. So while we develop or modernize the applications, legacy applications to AWS, we should also consider that in mind, and having an effective secured network architecture will make your application or enterprise secure, and at the same time it helps in resiliency and scalable architecture for the future as well. So understanding this network at least a basic understanding about the network fundamental services will be critical. Few days back, there was a summit happened at Bangalore. So that's the AWS Summit and the Community Day, and there the evolving network patterns has been discussed and so on. So network, the idea of network is very network, especially in cloud, it is called software-defined network models. So previously, those of you who already worked with the traditional network models may know this, like there will be a lot of traditional approaches involved, which includes physical hardware devices, networking hardware devices, switches, routers, and so on. And in most of the traditional organizations, they are involved a separate server room which handles all these things, which then connect your servers and your applications. So now the modern trend is that in the cloud, everything is software defined, and this network infrastructure is also defined using the software in a kind of an infrastructure as a code model, so that you can define your network architectures using purely in code. You can define your network architecture in AWS. You can use CloudFormation. Also, you can use other forms of infrastructure as code, like the Terraform. Similarly, for other cloud providers as well, there will be different services out there. So the idea is everything is defined using software as a code model, so that this offers the possibility to rapidly evolve as well as to revert back as well. So once you have your services defined in the code, so this is a kind of a principle which AWS and other cloud vendors follows. So once you have your network infrastructure or your architecture defined in the source code, it will give you the possibility to upgrade or revert back as needed, and it can fundamentally help in a continuous deployment model. So you can have frequent releases, and you can have network architectures which can define in a few seconds, and within that time those architectures will be implemented or gets deployed because of this on-demand cloud mode. So, and the another advantage is that you will be pay only for what you actually use. So these are some of the advantages that you would get from defining it as a software model, a software-defined model. Okay. So, so here you can understand that the cloud networking fundamentally differs a great deal from the traditional data center networking strategies. In the traditional, like we discussed, it involves the physical switches and routers. But here in the modern concept, you work with software-defined networks. And this gives you unlimited flexibility and scalability. So you can evolve to any. So you just have to pay for whatever you use or consume. That's the thing. So this is the basic understanding. And next critical thing to understand this is that while modernizing an application to cloud, you should create isolated environments for your application. So this means that the blast radius can be reduced in case of any issues. So the concept is like, just like in the software, we used to create modular microservice architecture. Similar way in network also, isolated modular networks or environments are created so that it holds a related set of services which then communicate with other networks. So you can have unlimited networks in your cloud, in your AWS account. This is called the VPC, Virtual Private Cloud. You can find this in the AWS console. You can simply search for VPC and you can find this. So you can define a VPC model there, and you can have unlimited VPC models depending on the need of your application. So you have to balance it. Like you don't have to create every VPC for every resource, but you can group related resources together under a VPC, and then you can even connect other VPCs as well. So in the case of an evolving architecture model, modernization architecture model, if you already have some of your services in AWS inside a VPC, you can connect that VPC to other VPCs which you plan to evolve as well. So this way it offers a lot of flexibility. The cloud offers a lot of flexibility in this. Okay. So we will start off with an understanding about the AWS network platform and architecture. So a comprehensive networking tools are available. You can simply log into AWS console and you can see a lot of services. And first one we will be defining is like discussing is about the virtual private cloud. So virtual private cloud is just we discussed, like you can create isolated a dedicated network and you can think of it like as a kind of a mini data center where your resources resides. So it's kind of an isolated customizable network environment within the AWS region, and you can define as many VPCs as you can, and you can use another service in AWS which is called the AWS Transit Gateway, which can help you to connect to these multi VPC. So you can define as many VPCs as you like, and then AWS offers another service which is called the AWS Transit Gateway, which offers possibilities for connecting to multiple VPCs. Then in the case of the architectures that you are going to modernize, legacy architectures you want to modernize, sometimes there is a need for you to connect your on-premise infrastructure to AWS Cloud, and you can use AWS Direct Connect or VPN for that cases. So the reason for keeping some of the contents in the on-premise system is due to regulatory or the compliance reasons, especially in organizations like healthcare and the defense. Some of the data should be kept within the on-premises due to their compliance requirements. So AWS offers services like Direct Connect in those cases to connect the critical components in on-premise, and then using a service called AWS Direct Connect, you can connect your on-premise resources to AWS Cloud and connect to other VPCs so that you can get advantage of both the world, on-premise as well as on the cloud. And also, when it comes to the networking, another component worth mention here is the AWS CloudFront. This is a global content delivery service which can help you to deliver your applications in a faster way by providing services in edge locations. So the service will offer security as well as it provides some form of a caching so that the customers who are near to CloudFront can take advantage of that rather than depending entirely from your regional EC2 instances or whatever services, other services. Then also, this is the era of generative AI, and AWS has a service called Amazon Q, which enhances the networking experience with AI-powered architecture recommendations. It automatically suggests optimal network topologies, which can help you to define the architecture. Not only that, for the applications that you already deployed, the Q can help you to identify some of the security vulnerabilities, and it can also provide some of the intelligent guidance for complex network region designs. So it's a kind of an intelligent system which understands your requirements, so it can provide intelligent guidance on complex multi-region network designs. Same time, it considers the cost performance, security. So you will get an efficient network resource with the help of these old resources. Now, again, coming back to the VPC, everything in AWS networking begins with the virtual private cloud. So virtual private cloud, I am reiterating this point again and again so that you will get a good understanding. So VPC is again actually a kind of a isolated network within an AWS region, and you can define your resources within that VPC. So by default, actually, when you create a resource in AWS, if you have a new account in AWS and if you create a resource, say for example an S3 bucket or something, it's actually not S3 bucket, actually another resource. It's S3 is a global resource, but another resource like an EC2 or something. Usually at that time you can see by default an VPC gets created and it will be defined inside there. So this way that's automatically creates for you, AWS creates for you for some resources, but at the same time you have the flexibility to create a VPC, define a VPC by your own, and then you can define, when you create a resources, you can set your resources within that VPC so that it provides a kind of an isolation. The reason for this is based on the concept of zero trust principle, where a set of services you defined can be inside a VPC with its own ACLs and security groups defined, so that it reduces the chance for an attack, and only the authorized resources can access your resources inside the VPC. So in this way, in organizations, you can see a lot of VPCs defined with its own ACLs and security groups, so that only the authorized resources will get access to the corresponding resource, and this reduces exposing those services to the outside world. So critical resources like the database or the servers should remain inside a VPC. And here I want to mention one more thing inside the VPC, which is called a subnet as well. So you can define a public and a private subnet inside the VPCs, and resources you want to keep under strictly private can keep inside the private network so that they won't be exposed to the outside public. And same time, resources that you want to define in public can be defined inside in public subnet. So these are public facing services where the outside world can connect to that. So in this way, you create an isolated boundary between these, and then these services can be connected through each other as well. So similar way, multiple VPCs can also be defined, and then it can be also interconnected. So while defining this VPC, you need to understand about the two concepts, which is the subnet concept and also the concept of load balancer, NAT gateways, and so on. So let's start with the understanding of the subnet first. So you will be creating clear public subnets and private subnets. Public subnet will be created for internet-facing components like the load balancer and NAT gateways, and you will be defining private subnets inside a VPC for protected resources, including your application servers. So this includes EC2 instances, it can be your container instances and so on, and then the databases as well. So while defining this VPC, the key to scalable networking lies in the proper CIDR planning. So this is where you define the network in CIDR. This is the range of network IP ranges that you want. So you'll be defining it upfront during the creation of VPC, and then there is a service called modular route table that you need to design, and finally you have to also define the security. So in AWS this is called the layered security model, and you define this through security groups and network ACLs. So you start with that in the VPC subnets, defining security groups and network ACLs, and subnet also we define like public facing components in public and the critical components or the protected resources under the private subnet. Now when your application grows or evolves, you need to have multiple resources and you will be creating different VPCs. At that time, you need to face a critical architectural decision to choose whether to choose a VPC peering or an AWS transit gateway. So if there is a limited number of VPCs that you created and you want to interconnect between these, VPC peering is the ideal way. So that means if you have a few VPCs, let's say 5 or 10 VPCs, you can have VPC peering. But what about if you have more VPCs? So at that time, VPC peering may not be feasible because it becomes the architecture more complex. So at that time, you need to have a different service, which is called a kind of a hub-based model, which is called the AWS Transit Gateway, where you can connect multiple VPCs together. Then, so now you get a good understanding about the foundation, about the VPC subnet and the different ways by which it can be connected. Now let's look at some of the ways by which we connect from the on-premise system to the AWS. So this is especially useful for hybrid scenarios and the modernization scenarios. So in the modernization, what happens is in most of the cases, ideal cases, you won't be modernizing the entire application at once. You will go like a kind of a model called a triangular model, where we'll start with modernizing one part of your applications to cloud and then the other parts. So either of these scenarios, you need a approach to connect from your hybrid or the on-premise systems to the AWS cloud system. So AWS provides two approaches for that. One is the direct connection, and then the kind of a VPC peering can also be used inside that way, and also there is a way called transit gateway also can be used, which acts as a central hub, allowing you to connect many VPCs through a single point of management. Then direct connect and also the virtual private VPN connect can also be used to connect from your on-premise systems to the AWS cloud. So the key takeaway here is like VPC peering works for smaller, simple architecture, but as the complexity explodes, the transit gateway keeps things manageable. So now let's look at some of the customer stories that about the different enterprises that adopt this kind of AWS network services. So you will get a better understanding about how they are using that. So one of the organization, financial service organization, JP Morgan Chase. So they implemented a comprehensive networking architecture spanning across multi-regions using AWS Transit Gateway, then the AWS Direct Connect. So the AWS Direct Connect actually helps to connect with from the on-premise system to the cloud. And then the Amazon Route 53. This service we haven't discussed yet, but it's a kind of a way by which it can resolve the DNS so that it can route the traffic to the right instances. So they are using, the JP Morgan is using these services. So their network design spans globally. So they use their global network design to support their real-time trading applications with sub-millisecond latency. At the same time, they want to maintain strict security isolation between the business units. So around 40 plus countries, they have different networks, and they are connecting that to each other, and while meeting regulatory compliance requirements and also the other audit considerations as well. Now, another one use case which you can find in the AWS documentation is about the Disney Plus. So Disney uses the Amazon CloudFront and the AWS Global Accelerator and also the AWS Transit Gateway to build a content delivery network supporting over 100 million subscribers. So the reason why they choose Amazon CloudFront, because this network architecture automatically routes traffic to the optimum edge location. So that means customers gets the video contents cached on these CloudFront locations, which is called the edge location. So this reduces the video startup time by 35%, while at the same time, the system, this entire network system is scalable as well, so that in times of content releases, these services can handle massive traffic spikes. And also this multi-region design. So they have a multi-region design. This provides 99.9% availability and with automated failover capabilities as well. So in case on network in one region fails, it can automatically hand over to another network so that the service will be resilient as well. Then also several healthcare organizations are using this one. Then when it comes to the e-commerce sections, so one example of an organization which uses the AWS network. So when it comes to the e-commerce, one organization which utilizes these AWS network resources is Shopify. They had built a global distributed network architecture using AWS Transit Gateway, Amazon CloudFront, and AWS Global Accelerator. So the goal of their design is to automatically handles or scales to handle, especially they have a sales called Black Friday where the traffic can spikes. So during that time, they want to maintain a consistent performance across all regions. So this architecture will help in that. So these are some of the different use cases which you can of different organizations who actually use this AWS resources. Now, so the critical components that you can see here is Amazon VPC, then the security groups and the different subnets, then the connectivity tools like the internet and NAT connectivity tools and so on. So we can dive a bit more deep into that. So let's start with the VPC. So VPC is your private network in the AWS cloud. You can think of it as your own data center where you control your IP addressing, routing, and security. So every VPC exists within a single AWS region, and it can span multiple availability zones for high availability as well. Then within the VPC, you can define the security controls. Security groups acts as a virtual firewall for the different resources like your EC2 instances, controlling traffic at the instance level. So there is another group of security control which is called the network ACLs, which provides subnet level security acting as an additional layer of protecting. So the simple way to remember the difference of these security groups versus ACL is security groups protects the individual servers, while the network ACLs protect the entire network segments. Now, within the subnets, there is a need for connectivity between these all. So there is a need for internet and NAT connectivity. So Internet Gateway provides, which is another service in AWS. Internet Gateway provides internet access for resources in public subnets, while the NAT Gateway, which is another service, enable outbound internet access for resources in private subnets. So sometimes your servers exist within the private subnets, but at the same time, you want to expose the outside internet to access those. So in that time, NAT gateways can be helpful. So the idea is that even though this architecture looks a bit complex, rather than having a single VPC with a single subnet and so on, but the benefit is separation ensures that your application servers remains protected while still accessing the different internet resources. Then once defined these architectures, network architectures, there is a need to monitor this as well. So AWS service also provide a lot of other services which can help with the monitoring. One of such services is called the VPC flow logs, which capture network traffic information, especially for the security analysis and troubleshooting. So this is very critical because this is crucial for understanding the different traffic patterns, identifying security issues, and it can also help to optimize the performance as well. So this VPC flow log, you can think of it just like your security CCTV camera that always recording what's happening so that you can investigate when needed. So these are some of the components. Now, imagine you are part of an organization and you are in a project and you want to start working on this. Usually, like I mentioned in the start of this episode, there will be a dedicated team specialized in that, especially this network and architecture consideration. So they define everything using some form of an infrastructure as a code tool, which is either the CloudFormation or in some organizations, they will be using the Terraform as well. Terraform especially helps with actually in multi-cloud scenarios where you can define these resources for different cloud providers. So, you can define a single Terraform and with some minimal settings, you can switch it over to multiple providers. So for the most of the multi-cloud provider scenarios, they will be using Terraform. But when it comes to the AWS, AWS have its own infrastructure as a code tool, which is called the CloudFormation. You can find that from the console as well. You can define the CloudFormations there. You can run it, test it, and so on. So ideally, everything, once the network has been defined, it will be made in the CloudFormation format, and then that will be used, that will be stored inside a repository so that you have the flexibility to have these network architectures in a source code format so that you can make incremental changes, revert it back, and so on. And this can help in auditing as well. So, so while defining this VPC, make sure to start with the proper CIDR planning. CIDR, as we discussed earlier, it's the way by which you define your network range. So choose IP address ranges that won't limit your future growth. So a common mistake that is happening in most of the cases is the organizations mistakenly picking ranges that were too small. So this limits the future growth. Second thing is like design your subnets with a clear public and private separation. Usually, when you start working on a new modernization or a new project, usually in most of the cases, sometimes it will start as a kind of a POC where you will start everything defined in on single subnet, and then you will work on that. There won't be any clear public or private separation, but having a public and private separation is very critical. So design those public and private subnets with a clear separation. You can have it later as well, so that won't be a problem because these changes can be incrementally made. But the point is, before it goes to production, have a clear designed subnets and with a clear public and private separation. So the easiest way to understand this is on a smaller application. There will be public subnets for load balancers and NAT gateways, and private subnets for your application servers and databases. So this is a kind of a general concept that I am mentioning here. For serverless, this will be different, and for different services, these concepts will be different. So this is applicable for cases where you have an application hosted inside an EC2 instance, and then you want to expose that to the public. So in that case, having a simple separation like a public versus the private subnets with the load balancer and NAT gateways and private subnets to host your application server and databases will be sufficient. So again, different services are different models. So for AWS Lambda, this will be different and so on. Their it automatically, the Amazon automatically handles the scalability aspect so that lambdas will be spinned up based on the resource. So in that case, the load balancer and NAT gateways are not a concern there. Then once you define this public and private separation and subnets, then implement the security groups with the least privileged access so that that will allow only the traffic your applications actually need. And finally, this is not the least, but it's an important one, like enable monitoring and net tools like VPC flow logs from the day one. So the reason for this is in case if any issue happens, this can help you to troubleshoot easier. So there will be a separate session coming up next, which can help you to select the best choices. Like we barely touched on some of the basic tools, but as your application evolves, you need to have a decision to which service to choose, whether you need to choose a VPC peering or a transit gateway and so on. So these are some of the considerations you need to have. But at this stage, for the start of an application or a modernization journey, these information should be sufficient, whatever we discussed. And the VPCs, the subnets, and the gateway NAT, and all these remains as a basic building block from which you will be building your application to the next level. Now, these are the basic things, the foundation things you should understand. So log into your AWS console and find out the networking services, create a VPC, and then create your resources inside that, define the subnets, and you will be deploying your resources inside those subnets actually. So have the VPC subnets ready first, and then make your application make your resources inside that, and then set the security groups and access control restrictions as you required. And finally, you can do all of this in a UI based format inside the console, where you will be either drag and drop, and you will be clicking, providing some information, and then you will be creating these resources. But finally, you want to automate this. So what you need to do is you have to either define all this from the start using some form of a infrastructure as a code tool called the CloudFormation or Terraform, either at the start or at some middle point of your application development. You should define these so that this can be set in the deployment pipeline. So manually creating this is not a ideal way in enterprise scenarios, especially because it limits the flexibility, and in case of an event failure, it's hard to spin up in a different region. So defining this in an infrastructure as a code is critical even from the start of the modernization journey. Then coming to the next section, we will think about some of the features that are provided by these services from AWS, so that you will get a good grounding of these services. So previously we have discussed that many of the major companies, we just randomly selected a few examples like Shopify, the Disney, JP Morgan, and so on. But actually, other than that, so it's the main thing about the AWS cloud services is that AWS done the extensive research, and they have done these services in a way that it supports the major activities inside Amazon, because Amazon handles petabytes of data daily, and they need a massive scale. So more than customers, they need this first. So they developed these services, and through the AWS services that they are offered, actually other customers can advantage of these things. So the full advantage you get from these AWS services is, especially when you use the serverless, where you just use the services and AWS handles the remaining things. But this is a network focusing section, so we will be thinking in terms of network related services. So AWS, because AWS needs to handle that much scale and security is one of the critical considerations for Amazon. So security and compliance at scale is there one of the main criteria behind this. Whenever Amazon creates a new service, they always consider these two important factors, security and compliance, whether it's S3 or something like a network service or whatever. That service should be resilient, scalable, and same time no compromise on security. So coming to the enterprise grade level security, these services, especially the network services, are built with security as a foundational principle. All the network traffic is encrypted by default during the transit. And also comprehensive logging is enabled, and monitoring capabilities can be enabled through the VPC flow logs and also the AWS CloudTrail. So CloudTrail is an audit service which helps you to identify who is doing what inside the AWS resources. So in AWS, the concept of identity and access management, which is handled using the IAM service in detail. So there you can define different users. You can also connect your existing infrastructure identity, like the Office 365 or whatever, Azure Active Directory, whatever, to that IAM, and you can have it. And in addition to that, you can also have other the identity providers as well connect to the IAM. So basically that means IAM will have a comprehensive set of users and group, and whoever who is doing what anything on that different resources, those all can be tracked through the AWS CloudTrail. In addition to that, the VPC flow logs also offers a kind of a security level function, what's happening between these resources. Then in addition to that, there's another resource called the AWS Network Firewall that provides advanced threat protection with managed rule groups, and also it provides custom filtering capabilities. So these network firewall and other tools are integrated with the AWS Security Hub. The need for that is AWS Security Hub offers a centralized security monitoring with automated incident response. Then when the scale increases more, especially for organization, one account may not sufficient, especially for the purpose of maintaining different resources. Having everything within one account is actually difficult to manage. So usually that a concept of multi AWS account is quite common in most of the organization, and because of that, multi-account network architectures can also evolve. And in those cases, AWS offers a service called AWS Organization, which can help you to manage all these different multi-account network, but at the same time, that will remain under a single account as well. So this way, AWS Organization help to group the related account networks. So then this is one level of security we discussed. Then the second thing is organization should have the compliance and governance framework. So this is one form of security consideration. Second thing is AWS provides a lot of services, and these should satisfy the compliance and governance framework of different organizations. So the networking services which we are discussing, they all meet the strict compliance requirements, including HIPAA and FedRAM. And for regulated industries, AWS provides specialized compliance programs and audit-ready documentation. So this means that the security is kind of a shared responsibility between AWS and the customer. So AWS shared responsibility model, which is defined in the well-architected framework, defines that AWS handles the infrastructure level security, patching the services and so on. At the same time, organizations should focus on the application level security. So it's like a kind of a combined responsibility between the account holder or the organizations as well as with the AWS. So now the next question, majority of the customers might ask is, what's the return of investment of this? So actually there should be some level of a research needs to be done on that, but on a general level, I will define some of the trends that we can see across the organization. So AWS networking actually follows a kind of a usage-based pricing model that aligns with the actual consumption. So on a typical study or a typical survey, it's found that organizations typically see 20 to 30% cost reduction compared to traditional network infrastructure, especially because they are eliminating the hardware procurement, reducing the operational overhead. And here in cloud, we have the option of a pay-as-you pricing model for data transfer and process. So we pay only for what we actually use. Second thing is like the network optimization tools that is inbuilt within the AWS console help you to eliminate unnecessary data transfer charges while maintaining performance requirements. Similarly, also with the help of Amazon Q and other agentic AI, that is agentic AI related tools that are upcoming, this can help you to evolve the architecture, network architecture in a cost-efficient way. Then some of the other benefits that you will get. So these are some of the by native feature you will get on your Modernization architecture in AWS is actually reduced operational complexity. Security will be managed by AWS for their infrastructure level. So you don't have to worry about patching and maintaining the security patches and all. But while still you need to take care of the application level security, defining who can access, defining subnets, private subnets, public and so on. But again, the main heavy lifting of having the infrastructure level security will be handled by AWS itself. Then also the cloud native network, which we discussed, is a kind of a software defined model. So because you have the defined network architecture within the within the repository as a source code, it enables you to have faster deployment cycles, improved disaster recovery capabilities, and also it provides unlimited scalability where you can scale the application, scale the networks as needed. So the operational transformation towards infrastructure as a code delivers value that exceeds direct cost savings. So in case if you don't want some resources, you can also delete and recreate it later within some seconds. So that seconds or maybe a few minutes, you can spin up the application. So this was not the case with the earlier approaches where you need to procure hardware and then set up the network resources, switches and so on, which will take time. And so in cloud, it's actually very easier. Then second thing is like, this is not just limited to the cloud. You can expand and have it a kind of a hybrid and multi-cloud integration as well. So AWS networking services integrate seamlessly with the other existing enterprises infrastructure through the AWS Direct Connect, AWS VPN, and also when you have multiple VPCs, you can connect it through the AWS Transit Gateway. Also, the not just this. So once you start the modernization, you start using some of the benefits from cloud. And in addition to that, one another thing that I would like to highlight is the third-party integration, especially using the popular network security tools. So this supports multiple monitoring platforms, AWS Marketplace, partner programs, and so on. So you have the flexibility to choose whichever service that you want to have. Then the vision of the AWS going forward is like a future where the network infrastructure is completely software defined and automatically optimized for application requirements. So this means edge computing integration, seamless multi-cloud connectivity, intelligent network automation that adapts to changing business requirement without any manual intervention. So these are some of the benefits. Now, those of you who are actually want to start working on these networks, some of the expert insights and best practices that I like to share. So, on a general, it's found that successful AWS networking implementation follows structured design principles combining proper CADR planning, which we discussed earlier. So plan your CADR so that it won't limit the future expansion. Then the modular architecture design. This is just like we define the software modular components. Network architecture should also be in a modular fashion. And security controls using the security groups as well as the ACLs, those and IAM securities, these are critical. Then the observability, that is another critical thing. Usually some in some areas have seen where the observability becomes an afterthought, like a monitoring will be implemented once the application is developed and so on. But actually in the modern architecture style, it should be considered from the day one and should be parallelly progressing along with the application developments. Then these are the things. Then another thing you want to check out is like the AWS well-architected framework. And this offers a comprehensive documentation where AWS documented everything related to a well-efficient networking strategies, especially the architecture and so on. Another thing that you can implement straight from the start of your networking design is to include tagging for the cost allocation. So tagging is not just for the network components, but you can enable it as a best practice for all your resources inside AWS. This has been already implemented by most of the organizations as well, where whenever they create a resource, tag should be mandatory, otherwise it's a security violation. So the idea here is to have a tag in place so that later this can help to gets reports or can take actions based on that tagging. So if you have a resources with a set of tags in AWS, you can make the changes on those resources, like you can scale down, or you can delete, or you can change that resources using those tag itself, or using some form of a infrastructure as a code tool like CloudFormation or Terraform. So this helps in actually automation as well. And another benefit is like it offers some form of a visibility where you can have a visibility into the different resources. So these are the things to consider. Then CloudWatch is another one resource worth to mention here. Even though it's not specific to the network, you can have CloudWatch to have a full view of the different resources that you are having inside AWS. So CloudWatch and VPC will help it. And also in complex network cases, especially when your application evolves, you can use AWS Network Manager for a centralized visibility. Then AWS also offers professional services to design comprehensive network architectures, and they also provide resources including AWS Architecture Center. You can search that in Google. Then they also have a set of networking workshops through the AWS Skill Filter and detailed best practices documentation. If you have an AWS account, you can also use the Amazon Q service, which is also another useful service where you will get the best practices from AWS. So it's a kind of a generative AI tool where you can query, you can chat with the queue and get understanding about the architecture. You can cross-check your architecture with AWS. Amazon Q can be integrated into your existing IDs like a Visual Studio Code, and you can query that. And you can also have an AWS Q CLI also, where you can authenticate with the AWS account, and then you can access it. So there would be a separate session episode about the Amazon Q that will be coming up. So before we wind up, have a quick overview about the different topics we discussed. So the understanding or making the best use of AWS networking is more than the technical understanding about it. It's about the building the correct foundation using the correct VPCs, subnets, public subnets and private subnets, and defining the security groups and ACLs, and to choose the best service for that so that it offers the organization's digital transformation and global scalability, and it also ensures the enterprise resilience. So AWS also provides a comprehensive tools and architecture patterns that help to build this sophisticated network infrastructure, whether it's a modernization application or an existing or a new application to support your business requirements. So the key principles are the proper foundation design, then scalable connectivity patterns, comprehensive security controls, and the correct observability. These tools are already available within the AWS. So then create a network architecture that can evolve with the business growth while maintaining the performance and security standards. And it should also be a cost effective as well. So get started with that. So thanks for tuning into the podcast. And for more details about this, check out aws.amazon.com/VPC. And to understand more about the networks, you can also look into the Skill Builder platform, which is the official training platform provided by AWS. You can check it. So thanks everyone for tuning into the podcast. Have a great day.